All right, welcome everyone to MDE. It's going to be a short day, just like it was a short day for the Math 154 class today. In fact, I'm not really going to go on about anything we did in Math 154 today because there's honestly nothing really to expand upon. The concept of correlation is not causation is actually a pretty simple one. It's just because you see two things go in the same pattern doesn't mean that one caused the other. It's pretty simple. The only thing we really talked about besides that idea and some fun examples, like the Nicolas Cage one and everything, those are always good for a laugh, was the R squared values. And again, something that's very simple and in terms of what you'll see on the homework and what you'll see on the final exam potentially, those are very simple questions. The closer you are to one, it's really good correlation. If you're closer to zero, it's really bad correlation. If you're dealing with an R and not an R squared, a positive value means it's a positive slope, a negative value means it's a negative slope. So again, I don't really feel the need to do a whole bunch of examples of that stuff because it's a pretty simple concept. Again, if you have a hard time uh, wrapping your head around it, I would suggest to first go back and watch that very, very short lecture from today again, at least the parts where we were talking about R squared. And then besides that, doing your examples. So what I want to use our time for today, and again, going to keep it brief just to have a fun example, since we're getting into chapter 9 with finances, where we'll talk about credit cards, mortgage payments, retirement plans, savings accounts, annuities, all this kind of stuff, I thought it would be cool to circle back to the retirement problem, but actually do a more real world example where we account for the fact that there's inflation. Our money is devalued at, on average, 2% per year currently. And I also wanted to break this up into a month by month cycle, which is going to be a little more complicated, and we're going to hit some speed bumps along the way. It's a good way to set things up for yourself if you wanted to make yourself a 40 or a 50-year plan in Excel, but it's going to take you some time to deal with some of these changes. So after we do this the more complicated way, what I'll do is I'll go back and say, all right, just to keep things simpler, let's do this on an annual basis, which will make the changes much easier to process since we're not making a change once every 12 months, it's once every year, which would be once every row. And I know I'm ranting on something that's not going to make any sense until we see it. So let's go ahead and get to our one example of the day that will be modified and shifted and twisted, and then we'll do some Excel, some charts and everything just to see how it plays out.
So I wanted to do a quick video on what I would call a realistic retirement problem. And the base deposit, depending on your career choice and everything, maybe that's not realistic, or maybe it's even less than what you could do. But this, I just want to point out the rate, and then we'll get into the problem. This $400 a month, it could be possible that your employer is contributing half of this. A lot of things that are done with 401ks, which is where you have an employer-sponsored retirement plan, they'll match the dollars you put in up to a certain amount. Now, this could be a 50% match, which would mean if you put in $2, they'll put in $1. It could be a 100% match, which means if you put in $2, they put in $2. There's a lot of different variables here. It depends on where you go work. It depends on their setup. They often have a cap on the contribution amount, like they'll say they'll only match up to $5,000, up to $10,000, whatever. But this is a pretty realistic problem, in my opinion, because let's say you do have a job where your employer is matching a one-to-one, so every dollar you put in, they'll put in $1, and let's say they'll do it up to $10,000. So that means you're only putting $200 of your paycheck in per month, and they're going to match it with another $200. Now, again, this doesn't have to be a 401k situation where it's done through work. You could also do this through an individual retirement account, an IRA, whether it's traditional or Roth. So maybe your job doesn't offer you any retirement plans, or maybe you're just supplementing it. So then that would be $400 out of your own pocket, because IRAs don't have employer matches, at least traditionally. There's always exceptions to rules, so I don't want to say without a doubt, but I've never seen one. And if you have, shoot me an email and let me know. rbeckner@tcc.edu. All right, so let's get into the problem. What we're going to do is we're going to set up an Excel file this, and we're going to get a little more detailed than what you may have seen in the past. At this point, you've probably seen me do things based on a year amount, and you have probably never seen me account for inflation. So that's kind of the two new introductions here. So we're going to assume that $400 is being deposited per month the first year of your career. Maybe we're about 22, fresh out of college. After that, each year you will increase your deposit by 2% to account for average inflation. Now, I can't say for 45 years that inflation is going to be 2% every year. No one can predict this. It varied wildly in the past. It will probably vary some in the future. We have the Federal Reserve that tries to balance it, but again, that's why I'm using words like average. So I'm doing a scenario, we're 22 fresh out of college, 4-year plan, and we're going to have 45 years of our work until we're 67, which is the traditional retirement age at the date of this video, so that you could get full Social Security benefits. Yes, you can retire earlier than that, 62, again, date of this video. You can get partial payment on your Social Security. IRAs, it's 60 or 59 and a half. We're not going to get into all those details. So it's just 45 years, nice round number. So $400 a month. We're going to increase that the second year by 2%, which means that we put another $8 in. Yeah. So that would be $408 that we'd put in each month the second year. And then the third year, we'd be putting $416.16, and you can do those calculations on your own. You'll see it pop up in Excel. And we're going to earn an average APR of 9% compounding monthly. Now, I'm making the compound interval the same as the deposit interval for various reasons, just to kind of make formulas that are outside of Excel line up with this. But the nice thing about Excel is we could have that working differently, but it would complicate the Excel file either way. How much will we have to retire on? Now, this number will seem bigger than what it actually would be 45 years from now, because this is accounting for inflation. So $1 million right now won't be the same as $1 million 45 years from now because of inflation. And we've talked about things like the CPI that can track that, but we can't predict the future. All right, so the things that we have here is that our principal, we don't really have a principal, we don't have a starting value, but we do have a monthly payment into this account of $400. Again, that will increase 2% each year. We'll account for that in Excel. Then our deposit rate, our R, is lowercase r, silly word, 9%. So the reason I use this number is because with inflation, accounted for, the typical rate of return of things like the S&P 500 over long amounts of time is about 7%. So this 9% bumps that 2% of inflation into it. So it is a fairly realistic number, but again, past results do not dictate future results. This is not financial advice, all that normal stuff. So it's just a number I'm using because that's the average up to this point that most professionals would say. All right, our time is 45 years. We do have an N because we're not compounding annually, we're compounding monthly, so that N is going to be 12. So this is essentially all we really need to set up our Excel file. We have our deposit, we have our time, we have our rate, our N. And you may or may not have seen the formula up to this point in the course, that the annuity formula. It's on your formula sheet if you've seen that by now. But you may not have used it up to this point. It's kind of like one of the last things we do. And I can introduce this a few classes before that. All right, so let's do this. We got our information, and I'm just going to kind of put this to the side. So our payment is $400. That's initially. It'll be a 2% growth each year. Then we have our rate, our APR specifically, which we said was 9%, our N, which was 12, our T, which was 45, years, and there we go. So let's set up our Excel spreadsheet like this. Let's have a date, and date is going to be very, very generic here. It could be just year, but then that's not going to really work because I'm going to have this done by month. So you may have seen me do this as a year, and then it's just year 1, year 2, year 3, year 4. So setting up your own file, which is the whole point of this video. So the first date, let's say this is you're going to start January 1st of 1995, which is obviously in the past. Then you could have this be January 95. And the next one would be February 95, and then March of 95. So I'm just going to make this some arbitrary date in the future that we're going to start. We're going to start January of 2030. So January of 2030. Now I typed Jan space 30, and then Excel figured out that that's going to be, they even put the specific day in, January 1st, 2030. The day doesn't matter. Don't focus on that aspect. Unless we were depositing daily, and then it would, or if we were gaining interest daily. So we'll have the starting balance for that day. Then let's put in how much money we add. So that's our deposit, money added, deposit, however you want to phrase that. I kind of like deposit more since I wrote deposit previously. And then we're going to have a column for our pre-interest balance. And I'm going to need to widen that column. Remember, you can take your cursor between the letters to do that. Some of these are going to need to widen eventually as well. And then after that, we can set up a column for our interest calculation. And then after that, we can have our ending balance calculation. And I am going to go ahead and just make some of these columns a lot wider because, well, the numbers are going to get big eventually. Okay. So what do we start with on January 30th? We start with $0. We have not put anything in here. And move this stuff. Remember, you can highlight a section, grab the border just to move it to somewhere else, a little more in the screen. We're going to deposit $400 for that first month. Now, this is going to get a little tedious because of how things are going to be laid out, but that's kind of the point here. So $400, and then the pre-interest balance, well, we're going to add what we started with and what we deposited. So we go equals, and then we just take the cell plus the cell. I have my date off screen. There we go. The interest, this is just going to be the product of the APR divided by N, which gives you the periodic rate, and the balance. So the periodic rate would be the 9% divided by 12. And you can actually use fixed cell references for these. So we can go equals the 9% divided by the 12. So that would give us our periodic rate. But I want those fixed so they don't ever move. So we're going to double cash each of those. You should remember how we do that. And we barely get any interest because this is, oh, I'm sorry, that's not even the right thing. I forgot to do the times. I was about to goof. So that's just the periodic rate, but then we multiply by the pre-interest balance. And there we go, that makes much more sense. So we're gaining $3 on that $400 that we have in the account, which is actually pretty significant because we've got 9% interest. And then our ending balance, this would just be the sum of what we had before we gained interest plus the actual interest that we have. Now, this is got a little green little arrow in the corner here. If you hover over it, it says this formula differs from the formulas in this, this formula in this cell differs from the formulas in this area of the spreadsheet. That's something that it'll Excel do sometimes. Occasionally, it's actually telling you you goofed. But in this case, everything is fine. I can tell you that everything has been done correctly. So if I just grab this date and do that, you can see that it increments by months because the thing I typed in was a month and a year. So I can just do this forever and ever and ever. And we're supposed to be going for 45 years. So if we start in the year of 2030, 45 years plus that would be, well, 30 plus 45 is 75. Now, this is going based on months, so you can see this is going to take a long time to get to. So we need July of 75. Oh, we went a little too far. So let's just, oops, that's moving it, isn't it? Let's fill that a little less. Fill that until we get to the 75. There we go. So, I mean, look how how many years that is. I zoomed the wrong way. There we go. So let's go back to the top. And our starting balance, well, this is the thing that has to be linked to the ending balance. So we need to go equals. We go equals, and then we just click where the year one ending balance is. And that will be good for the entirety of this spreadsheet. So I can then just drag that all the way down. I'm just going to drag it down for about a year's worth for now, just to get an idea. But everything looks wrong for now because we need to fix some of this stuff. Now this $400 deposit, if I drag this down, whoops, wrong thing. I just clicked the wrong thing for a second. And we can see all those are $400. The pre-interest balance is $400. Well, let's see if we drag those down. Oh, well, that one looks like 803, which kind of makes sense. If we had 403, then 400, we should have 803. The rest of these don't make sense yet because these are still zeros, but we can just keep dragging formulas down. Let's drag the interest formula down. Let's drag the ending balance formula down. Now everything is starting to make sense. And in a matter of 1 year, we have managed to deposit, let's see, $400 times 12. Well, that would be $4,800. And we now have $5,041, which means we've gained $2,041 in interest. Did I say 2,000? I meant to say 200. If I said 2,000, I meant to say 200. So we deposited 4,800. We got $241 for free, which is nothing crazy, but we started out with nothing. We understand these exponential curves. We start out with nothing. We don't have much. So what do we do to keep moving forward in this? Well, we can still continue dragging our starting balance down. Let's just go for one more year. That scrolled really quickly. So let's go through all of 31. There we go. And again, it'll look goofy for a while. Now for the deposit here, we want that to be larger. So we actually need to say that this is equal to the previous one of $400. And then we have to do times 1.02. Now, why am I doing this times 1.02? It's to account for inflation, because we said each year we are going to inflate our deposit by 2% to account for inflation. So now we're going to start depositing $408. And it started showing pennies here, just because Excel, it could have shown them before. And in fact, if you change these to currency, I had typed that dollar symbol initially. If I had actually clicked this button, then everything would have done that, which is fine, but it'll just start seeing that eventually. All right. And in fact, you know what? Let's just go ahead and have all those, because these interest amounts are not exactly whole dollars. It makes them look like that. So there we go. Now the numbers are exactly accurate to the nearest penny. Before we were just rounding to the nearest dollar, which I'm sure all you really care about is the nearest dollar. So it wasn't the end of the world, but this is just more accurate. So now we have our $408 deposit. So we can drag, and I'm just going to drag the rest of these three formulas down all at once for the remainder of that 31 year. Now, if I drag this one down, though, that was a formula. So that's going to keep making the deposit bigger, so that doesn't quite work. So I need to just type 408 in the next one. And that's not formatted to currency. And you could just format everything to currency all at once. There we go. And that one, boom, there we go. And now that I have something that's just type 408, I can drag it down. And there we go. So now I've made $408 deposits every single month of 2031. And then for January 2032, I'm going to take that last deposit, but I'm going to bump it up by that 1.02. So that says we're increasing the deposit by 2%. So that the next year we're depositing that number I said earlier, 416.16. And then you got to drag all these other formulas down for the entirety of the 32 year. At least for these three, you can grab them all at once. Fill down like so. Now that 416, I have to go to the next one and actually just type the 416.16. So like I said, this gets a little tedious, but then I can drag it down. And we can just keep going. And in the interest of time, I'm actually going to stop with this example here, but we can see, all right, after 1 year's worth of time, we had $5,000 roughly. After 2 years worth of time, at the end of year 31, we had $10,000 and some change. And then at the end of the third year, we've got almost 17,000. And look at this interest column. It keeps going up, it keeps going up, it keeps going up. So that's really nice. But what I want to do is I want to redo this problem. Because while if you want to track this as you're continuing on, it's not the end of the world, but you keep having to just play around with this deposit column. Now, this example is how you should be doing things in the real world. You should be depositing monthly. So that's why I'm showing you this, but then just kind of understanding that maybe it gets a little tedious. Now, what you might say is, well, maybe I can just copy 1 year's worth of stuff. Actually, I would copy the second year because that's where we have that formula in. So if I copy the entirety of this, right-click, copy, let's see what would happen if I put that here. Now, let's see if it says the 408, the 448, or whatever all the numbers were. If I hit paste, and paste is really weird in Excel, so I'm just going to use Control-V. And that worked out there, but these didn't. So let me teach you another way you can fix this. I know I said I'm going to do something else, but just give me a minute. So instead of just saying, all right, well, that's 408, you can say that the next 11 of them are equals this cell, but let's just double cache it. So that way, this one will say the same thing as the January, which had the formula, but it's not got the formula, it's just referencing the cell. Now I can drag those down for the rest of the year. And there we go, they're all the same. That way, when I copy this year, put it one below, see, that's good. But again, these are not right, so you just have to fix it. There's just lots of different ways you can do this. So you go, all right, Mr. Beckner, I don't really want to set up 45 years of this spreadsheet. And I go, that's cool, I understand that. So instead of doing this by month, let's just set up the problem like we were going to do the deposits at the end, at the beginning of each year. So again, this isn't how you would do it in the real world. It's just going to make it easier in Excel. So I'm just going to copy all that. I'm going to start a new file. Making these wider. So now instead of doing this by month, let's just say 2030. That was weird, 2030. I think it's got that cell is formatted. Shoot, okay. Sorry about this. We're gonna start a new one again, just to get that. So the year 2030, starting balance is $0. I'm gonna go ahead and format all of these to currency. So this is the actual problem you would wanna set up to make your life easier, which again isn't super accurate, but it works. So starting balance is 0. Then we're going to deposit the whole year's worth in one balloon payment on January 1st. So that's $4,800. That's 400 times 12. So the pre-interest balance would just be equals what we started with plus what we deposit for the year. Now this is kind of assuming the year 2029, we earned that $4,800 deposited. Then we do the deposit on January 1st, 2030. Our interest, this would be equals. Now, I don't need to do a periodic rate. I can just do a regular rate. So the 9% times the pre-interest balance. So 0.09 times pre-interest balance. That's how much money we get for free for the whole year. And then the ending balance is just the sum of what we had before the interest plus what we get in interest. Okay. So if I drag this number down, let's see what happens if I fill that down. Oh, it wrote 2030. So remember, you can type 2031 for the next year. You can highlight both of those, then grab the fill handle and drag down. And we want 45 years, so we'll go to row 46. All right. The starting, this is where we have to link to the ending. That's the only time we have to do that. The rest of them we'll be able to autofill. Now the deposit, we always want these going up, so this is going to be perfect. Each year's worth is going to be what we deposited the previous year times 1.02. That's our growth factor. And it's not going to have all that silliness between each month because we're not going to increase, we're not going to worry about increasing on the first, excuse me, the first day, I'm sorry, first month, and then not the second through 12th months. We're just increasing it every year. All right, the pre-interest balance, let's just fill that formula down. The interest balance, let's fill that down. The ending balance, we'll fill that down. Let's zoom in a little. Let's widen columns. All right, so now if I highlight this whole row and just drag it down one, everything looks like it works. This starting is linked to the ending from 2032 to 2031. This deposit has gotten 2% bigger than the last one. That's what I was mentioning. I don't have to do and just repeat the numbers and then do the formula 12 months later and any silly jazz. The pre-interest balance keeps getting bigger. The interest grew by about $500, then about another $500, and that'll keep picking up steam. The ending balance is getting bigger. So let's see, from 2030 to 2039, that would be 10 years worth. You got 85 grand in 10 years. That's amazing. How about in 20 years, so to the end of 2049? Now we're at $307,000. Now, what if we go all the way down to our retirement? We are at $3.4 million. So you might be wondering, well, how does this account for inflation? How much money is that in today's money? Well, let's say your goal was $1 million. That's what you wanted. $1 million sounds like a lot of money still. So this 2% inflation every year, that's going to happen 44 years because it doesn't happen over the first year. So a way you can get your inflation factor is you just take that growth factor of 1.02 and you raise it to how many years of inflation. So this is just the basic idea of principal times growth factor raised to the amount of time, which was the very first formula we gave you back in chapter 6 on your formula sheet. So that basically means that every dollar has now become $2.39. In other words, a dollar today you would need $2.39 in the future to buy the same thing across all goods. Remember, all goods don't inflate equally, but this is a good start. So if you just took what we have here, this $3.4 million, I don't know why I did 3.4, because I said it, 3429907.25, and divide it by that 2.39 value. That would give you an idea of about how much money we would have in today's dollars, which is about 1.4 million. Holy cow, that's awesome. And I bet you most of this, if you're doing it in an IRA, a Roth IRA, your interest could be tax-free, and you're gaining a lot of money in interest. If you just did equals sum, and then let me add up all these interests. So highlight and drag. You earned $3 million in interest. So if you were able to put that in a Roth IRA, if the Roth IRA deposit was going up with inflation, which I can't promise, it's currently a maximum of $6,000 a year, then you could have a lot of money tax-free. So please, please, please take your retirement serious. And if you're doing this in a 401k, unless you're military or something like that, they don't do Roth, so you would be paying tax on your interest. But still, that's a whole lot of money that you wouldn't have otherwise. So start your retirement as soon as possible. All right, so if you have any questions, you can, if you're a student of mine, you can email me. And besides that,
All right, so like I said, I thought that would be a really fun exercise. And yeah, so when we come back, we'll do some more stuff in chapter 9 on Wednesday after we've learned some new stuff first. And then I just figured I'd put up the whiteboard from our 154 earlier today in case you missed it. But per usual, besides that, if you have any questions, email me and we'll see you on Wednesday. Take care.